There's something I don't understand. Everything around me, these bushes, the fish living in the river, that bird up there, everything has adapted to its environment with its body. In fact, we, of course, ourselves, we have bodies that evolved. So how come that modern humans are so similar to each other, although they live in completely different environments? How come we do not form subspecies? Really weird. The first human species that spread the planet were our ancestors, Homo erectus. Maybe on the back of fire use or technological patience. These guys were super successful, and appearing somewhere between 2.6 million and 1.9 million years ago, they spread everywhere in Africa and all around Eurasia, from today's Spain to today's Korea and Indonesia. And when they arrived in all these different kinds of habitats, they adapted to the environment with their bodies. They evolved, like every self-respecting animal. And hence, we find a lot of different Homo erectus species. Homo floresiensis, the Hobbit, on the island of Flores in Indonesia, or Homo naledi in southern Africa. They were very, very different to each other. They were clearly separate species because they evolved to the local environmental conditions. But there was another branch, our branch. And somehow we stopped adapting with our bodies about 800,000 years ago. Because one of the adaptations, it seems, was extra large brains. And these large brains allowed us to spread the planet as well, but on the back of not adapting with our bodies, but adapting with our technologies. Tools, all kinds of tools, physical tools, like this pullover. Yeah, I'm here in Oxfordshire in the cold, and I'm not cold. I don't have to be furry because I'm wearing this. But also there's something else we adapted with, social technologies. So we had 800,000 years of existence in which these technologies allowed us to spread everywhere, all kinds of environments, and still stay the same species.
So Thomas is still...
I think he was having some early morning birthday
Yes.
juice.
So this is my grandmother and grandmother's head, sort of. And I thought because we always, we always have these graphs with, which is how many cubic centimeters. So I've got this system, I hope it's going to work, where we're going to measure out the brain size, how our brain evolved, but in an actual jug rather than in a skull. So I just collected all the bits and pieces to fill my grandmother's head with. Right, okay. And I had a coffee. Right, okay, so, it's time. Okay, let's go. Shall we move on? Okay, so let's make the last point. So this is where we were. The point was that the first bones for Homo erectus was found 1.9 million years ago. If my story is correct, then the actual evolution of this new being, the first was really, in a way, us and different from the Australopithecines and the chimps, was somewhere between 2.6 million and 1.9 million years ago. And this became an extremely successful species. So this species spread the planet. So coming from Africa, quite likely West Africa or Northwest Africa, spread in all of Africa, and then spread in Europe, in above the Himalayas and south of the Himalayas into what is today Indonesia. And it was adapting in his body. So like every decent biological being, when it gets into different environment, so you go from the savanna to a mountainous area or to a different kind of equatorial jungle, you're going to change your body. You adapt to the different environment in your body. So I'm going to show you some examples of how that happened. And then this being then gradually became something that is almost us, or we will have a discussion of whether that new being is Homo heidelbergensis. Let's give its name. All of these names, by the way, are flying around out there. So people are archaeologists, people working on human evolution. There's this abundance of species, and my suspicion is that there are too many. I mean, it's trivially too many of these. But this is not that bit is not my field. But anyway, so there's this new being, let's call it Homo heidelbergensis, that arrives at 800,000 years ago. And this Homo heidelbergensis also spread the planet. So there were many, many waves of spreading the planet. So these were much slower migrations than today, but there's no reason to think that they were not continuous migrations. And there's a really weird thing happened. Because while Homo erectus spreading the planet was adapting in his body, Homo heidelbergensis did not adapt in his body. Or there was some small adaptation. And most of the adaptation was somehow differently. And clearly they had to adapt because they were getting to the same places and Homo erectus was getting. So the question is, how did this happen? And jumping back to our mind today, it's sort of obvious. They adapted in technology. So the next bit of the story I'd like to tell is how this adaptation in technology happened. You can have tools that match the particle environment you live in, which is interesting. But what my interest is, and the story arc I'm telling now, Flores, is that you can adapt in your social technologies. We so often do not think about our traditions, our rules and norms as social technologies, but really that's what they are. They are ways for dealing with the environment. And so with that, of course, much, much later, the successors of these early Homo heidelbergensis then spread everywhere on the planet where humans can actually survive. So, and with that, you will be happy to hear that we finished the first segment. Let's move on to the 5 a.m. segment. Why did we not mess the planet up before? So once I got to this point in the story, something started to bother me deeply. And what was bothering me is that our ancestors arrived to the point of being able to adapt in culture, adapt in social technology and tools. So in many ways, these people 800,000 years ago were not that different from us. I will get back a little bit later at the end of this segment of how different they were. But I suspect they were not that different. But definitely 400,000 years ago, 330,000 years ago, they were pretty much the same beings. So how on earth is it possible that they did not mess up the planet, but now we do? Sometimes the explanation comes shooting from the hip, is that, oh, there were not many of them. And I'm very, very skeptical about this explanation, partially because I've seen people in the New Guinea highlands, and there were no proper statistics because every local chief, the money from the Indonesian government was coming per head, so every chief reported a much larger number of people than they were. So I had this little exercise of trying to figure out how many people lived on Irian Jaya. And I realized that there are a lot of people living on Irian Jaya. My estimate was 1.9 million people on the western part of New Guinea. And okay, so they were horticulturalists, so they were gardeners and not only foragers. And I will come back a little later how that comes about, gardening comes about. But once you are a biped that can regulate temperature, that has fire, that cooks, you have complex tools. So everything we know these guys had 800,000 years ago, your density is going to be high. So there are other reasons we think that they were not, many of them, because I can't think one particular reason why they wouldn't have filled up the space. Because today, people fill up the space. So one possibility is different kind of bottlenecks of the bits of the people who killed everybody else. We'll come back to this point of murder and war very soon. So anyway, so this really bothered me. So this is a story about that. So first, Homo erectus really rocked. By the way, notice the way this map is going. So half of the planet is, of course, the Pacific Ocean. So I will make this trivial point. Yeah. It's a very trivial point, but let's just rehearse it for a second. Yeah. So yeah. Americas. Yeah. So Africa. Yeah. And Asia, Eurasia, Australia. And then from here to here, it is a sea. And this sea almost certain wasn't crossed for a very long time. Even those who suggest that this sea was crossed early on suggest that it happened a few thousand years ago only. So definitely not hundreds of thousands of years ago. So the map that you see here is, the map that you see here is really the realistic map of humans spreading around in the planet. And in that, the evolution happened in the end bit, yeah? So happened in Africa. And then this was a very successful species, spread around in Europe, south of the Himalayas and north of the Himalayas. And one example for this is this Homo erectus subspecies, a successor species, on the island of Flores. This is the image here that you see is the comparison of a Flores human and a modern human. So these were very small beings, hence the nickname, the Hobbit. This is her. This is where the cave was found. This is the cave. And of course, there was much debate, is this really a Homo erectus species? But I think by now, everybody I believe thinks so. So this was a Homo erectus species found in Indonesia and present a few tens of thousands years ago. So survived for a very, very long time. And the island biogeography will tell us that on islands, very often you have dwarfism and gigantism, which is essentially what's happening is that islands carry much smaller number of species because there's just not enough space to build a more complex ecosystem. And as some species fall out, the space, the ecological niche for the other species changes, and hence you can have these very large giants, or you can have very small beings like the floresiensis, the Homo floresiensis that got to Indonesia. We also have other evidence from Homo erectus arriving to Indonesia on Java. Yeah, so when I was growing on there, it was called the Java man. So those guys arrived there. So there is evidence that Homo erectus spread very efficiently and adapted in his body. Yeah, so again, this is a small person and lived in a really, really scary environment. So look at that bird in particular. Those birds probably hunted these little hobbit-sized Homo erectus humans. If you think scary, that's it. But we also know that these guys had a lot of tools, and a lot of these tools were probably tools with which you are making other tools, your stone tools that you can use to make other wooden tools. So this early human, Homo erectus, then becomes a parallel species to our line, had tool, lived and dealt with a very complex environment, probably hunted elephants, were themselves hunted by others. So this is important because with that we can sort of project back what could have been the common ancestor like. Yeah? So we understand a little bit about not only the local adaptation, but the ability to adapt locally when you put up with this really scary environment that you live in and you survive in until a few tens of thousands of years ago. A similar story happened. This is from Southern Africa, from the Rising Star cave system, when another sort of sideline was found, Homo naledi. These were much taller than the floresiensis, but also relatively small heads. And those archaeologists who found them said that they were almost human. It was a very difficult thing to say. And there was something very weird about these guys because they were really upright, but the brain size was smaller than the brain size for our line, although they were living parallel. But even with that smaller brain size, they did something remarkable. Because the reason these bones were found is that they were at the end of a cave. So if you look at this cave system here, the caves, this is where all the bones were. So you'd have to get down here somehow, get through this crazy narrow point, climb up a really treacherous wall, go all the way in here, and then the archaeologists then had to go all the way down here to collect the bones. The way they were doing it is they were actually advertising for small archaeologists. There are a lot of videos up there on YouTube and the Net Geo sites about the story of this dig, of this archaeological site. It's really fascinating because not only they found completely unexpectedly, and this was a giant bomb, not only they found this, but they did science a new way, a different way, a very inclusive way, which was unusual. So anyway, the point of these guys being done here through this very treacherous bit, that how on earth did these bodies end up here? So, because they were all dead before. So you would have somebody dying somewhere out here, and you'd have to carry them down. And you see these bodies are, although the heads are smaller, the height is our height. So you'd have to carry them all the way down here. Then you'd have to carry them all the way up this very treacherous wall full of sharp stones just to drop them down here. What kind of behavior is this? Is this a burial? If they had a burial, what kind of thinking did they have? What do we learn from this about our own cognition? Can you have a religiosity much earlier than complex mathematics? A lot of the people who think about the origins of our species, use a concept called behavioral modernity. This was a tool, is a tool of an intellectual tool that allows complex behavior that appears in the same kind of body. So the difficulty that people had, archaeologists and evolutionary anthropologists had, is that you see a pattern of how the bodies are changing the past, say, 2 million years. And the body's change does not necessarily match the behavior that we see. And behavior modernity was a tool, is a tool, that allows assignment of really complex behavior that we see in humans today, but only a few tens of thousands of years ago, not hundreds of thousands of years ago. And I learned to, I think I can say this, I learned to hate this concept. For one, I'm a bothered with a somewhat racist connotation with which I'm trying to shed myself, because as a scientist, I shouldn't be bothered by these cultural norms. I should explain them, but I'm bothered by it. But I'm also bothered by it because it ignores the fact that there's so little that we would be able to see in other cultures today if they vanished and suddenly an archaeologist would arrive there 10,000 years ago, especially 200,000 years ago. I mean, you remember those guys in the New Guinea highlands with the arrows. 200,000 years from now, you will see nothing of their existence because everything will be rotten away, eaten away. So that point is now questioned by these guys. The idea of behavioral modernity, that you have the kind of symbolic cognition, that symbolic thinking that allows the complex religions that we have today, would come very late, was then really questioned by the fact that these people with much, much smaller brains carried their dead down in this cave through this really narrow point. It's called a Superman's crawl, because you need to be very, very small to be able to get through. It should be really Superwoman, because all the archaeologists were women actually. Yeah, and then up here and drop down. So this was a phenomenally important site in the Rising Star Cave, asking really deep questions about what is happening, especially what is happening with our language as well. What is happening with our own thinking and storytelling and religiosity. I will get back to all of this. Right. Okay. Let's do some. I think later. Heads we roll later. And then another revelation happened, but as it turns out in our own line, when in a small cave in Siberia, a little pinky was found. And this was a very important story for me, because this is the first point where you have some kind of, rather than a side branch found, like in the case of the floresiensis, the Hobbit, or the naledi, the human species that was burying its dead with much smaller head, these Denisovans turned out to be part of us. And they created something big. So this is the cave where a little pinky was found, a pinky bone was found and sent to Leipzig for the recovery of the DNA. And at this point, I should add something, that by now, the DNA sequencing from old bones is really exceptionally done. So the technique is that in the DNA chain, of course, from a bone, there are a lot of DNA chains from the different cells. Each cell would have the whole full set of the DNA. So you can actually, although it breaks up when we die, the DNA breaks up in smaller pieces, they're actually quite stable molecules. So even tens of thousands of years, you will be able to find segments. And we have a lot of segments, and these segments will be overlapping, because the break where the DNA breaks is not characteristic. So there will be overlapping points of breaking. So then what happens is that you have a powerful computer, you can actually match these up because you see an overlap here. So you can find the overlap here. Oh, suddenly you have this long. And then you find something else. Now we have this long, and you're, oh, this has an overlap here. Oh, suddenly you can extend this. You can actually gradually build up the whole DNA. So with that amazing trick, you can have the DNA for ancient beings, yeah, from a pinky. So this is what happened here from this cave. And what they found was really remarkable and important for me. And the reason is that when I was going to New Guinea, then we were visiting a mine. So this is New Guinea. This is the western part is Irian Jaya, obviously north of Australia. And if we go zoom in, yeah, this is these long mountains are the mountains I was showing on my shirt. Yeah, this is the Australian plateau is pushing against the plateau north of it and creates these wrinkles where all these multitudes of cultures live. Yeah, and here is a mine. Puncak Jaya is a peak which is snow covered, and this is near Puncak Jaya, up here in the mountains, is a mine. Let me switch to satellite, and you will see from the distance actually, because this mine here is at 4 kilometers high up. It is the largest gold mine on the planet and the third largest copper mine on the planet in one go. And this was up here. And when I visited it with this World Bank mission, they were already, I think, 1.5 kilometers down in depth. So what they're doing is that they're gradually just extending this, basically this hole. This used to be a 4.2 kilometer tall hill here, and now when I was there 2008, it was already a 1.5 kilometer deep hole, and they were gradually just cutting it down and carrying it down here with giant trucks. And we were very interested in it. I was very interested in it, and there was such a conflict between development and protection of the environment. New Guinea has not only exceptional cultural variation with 252 languages and 350 ethnic groups. This is Irian Jaya, so the western part of New Guinea, the Indonesian part. But it also has exceptionally high diversity of the ecosystem. If I remember correctly, 6% of all bird species and 8% of all fish species live here. Crazy. And most of it unmapped. So exceptional cultural value, exceptional ecological value. And by the way, who the hell was this 38-year-old Central European intellectual guy there to tell the locals what to do with their, I mean, it was really very conflicting what was my role here. But also, not only they have this exceptional value, but they have a lot of gold, a lot of copper, nickel, gas, coal, oil, incredibly good earth to grow stuff on, hardwood. So a lot of reasons to just clear cut the whole thing and get very rich very fast, which is what a lot of the chiefs wanted to do. The question was, right, okay, so how do you balance this out? And that was sort of my job, to figure out how to balance it out. And I failed miserably at it. Yeah, I mean, I very rarely, every 5 years or so, I go and look at Google Earth and just look at the devastation that happened to the forest. And, I had a chance at one point to to do something about it, and I failed at it. Anyway, so this mine had the mining company that was mining this was under a lot of international pressure to do less damage. And usually the pressure is less complex than the actual environment, and the answer to the pressure is even less complex than the pressure is. So this mining company, they decided that what they're going to do is they're going to build so this is where all the processing bits are. And they decided, Timika is down here. So they decided that they're going to build a mining school. And they're going to hire the locals to do mining. I mean, we're talking about horticulturalists with stone tools, yeah? The concept of metal arrived for the first time, not spread around, arrived for the first time in these cultures in the late 50s. Same for the pottery. This was used before it became mining. So these are cultures in which metal is a new concept. And who are, of course, very, very ready to be rich now and move into. So we were discussing satellite, being satellite. Imagine how crazy this is, yeah? So somebody who is now a chief, but had already 3 kids the first time he heard about the concept of metal, and now was discussing how to beam in internet, satellite internet for his grandchildren. I mean, just the incredible arc of technological change, and also our flexibility about it. I mean, that you can process all of that. Yeah. Anyway, so the mining company that was murdering this environment here was put a lot of international pressure, and what they decided they're going to do was to hire local people to show that they are really caring for the locals. It's a very weird colonialist idea what local means, and they were very colonial there anyway. So I was very skeptical about it, but it was interesting. So we've seen the mining company, and knowing that this Zoom is going to stay among us, and only 20 minutes will be edited out of it maximum, I will tell you actually how it was. So there was this guy, I don't know, maybe 60, very rasp voice, not from talking from a lot, but chain smoking, an Australian guy who had built and ran mining schools for locals for this company around the planet. And so he told us about his mining school. And what he said is that, they are very smart people. I said, I wanted to really know how smart they were, because there were these tiny little differences in the body of the Highlanders. So for instance, a lot of the Highlanders were wearing boots rather than shoes. So normally you would walk barefooted. And then when the colonialists arrived, different waves, they would bring shoes. So there would be, the whole thing would be peppered with missionaries. But the locals would wear boots and not tie them up, because they had somewhat wider feet. So I was very curious if there were any kind of differences. There was still the point when I didn't quite realize how completely similar we are to each other. Anyway, so they had these boots, and I was, all right, is there any kind of difference in behavior, anything special? And then he said, they're very smart. I said, well, how smart? Oh, they're very, very smart. So tell me. I said, oh, come, I'll show you. I've never seen anything like this. So we've gone out to a space, which was a driving school for the trucks that bring down the rocks from the mine. So these trucks, I've never seen trucks before, if you know mining trucks. These trucks were the wheels are twice my size. Yeah, so these are very, very large trucks, like every kid's dream of, every kid who's into trucks is their dream, the giant trucks. And then there was an obstacle course for one of these giant trucks, and there was one truck going really fast, and in and out and up and down and across and reversing and really going very fast. And so say, and then can you look who's driving? And there was somebody who's just barely old enough to be called an adult, a woman, a girl turning a young woman, driving the car. They're driving this giant truck. And he said, you know, a year ago, she didn't speak Bahasha. She didn't know mathematics. She didn't know how to drive. And look, she's driving this fast around and how good she is at it. And he said, you know, with raspy voice, you know, this is, everybody's like this here. I've never seen anything like this around the planet. So I put it aside in my head. We discussed this within the team, and nobody engaged really. It was a development economics team. And then I put it aside until I got to the point of the Denisovans, which was a few years later. So the Denisovans hadn't been even found when I was on New Guinea. Because weirdly, from the genes of the Denisovans, you can actually tell which population, you can actually check if there was any kind of interbreeding with other populations. And what they found is the New Guinea Highlanders had the highest admixture on the planet. So there was interbreeding between those who arrived, those, let's call it African Homo sapiens, who then mated with the European Homo sapiens called Neanderthals, and then they arrived on New Guinea, and then New Guinea had a population of these sort of Asian Denisovan Homo sapiens, and they were falling in love and having sex and making babies. And there were at least 3 waves. So this was not a one-off thing. This was like a love that lasts for tens of thousands of years. So they were interbreeding, and these populations had the highest admixture. And that was sort of in the back of my mind when the news about finding the Denisovans came out, when the gene sequencing of Denisovans came out. And the big debate in which a lot of people wanted to say that, the Denisovans and the Neanderthals were not really like us. They were different kind of people. And most importantly, they would regularly say they were stupider than we were. And I can tell a story in which there is some kind of selection pressures in the mountains that either makes you born smarter, whatever the foundations are, genetic foundations are, or have a particular culture of learning and you end up smarter. So we can tell a story about this. But if I don't want to engage in that, what I want to say is that I don't think what I saw from the genetic traces of the Denisovans in the New Guinea highlands would support any idea that the Denisovans were not at least as smart as the African Homo sapiens or the European Homo sapiens, the Neanderthals. These were subpopulations. And this is going to be important for my story of why our species is much older than the current narrative, common knowledge or common narrative. Before the Denisovans, a few years earlier, came the news that they're breeding between what they call the anatomically modern humans, which is really what means the African Homo sapiens, and Neanderthals. And I saw how many of the old guard, old guard is the wrong term, but how many people said that the Neanderthals were different people. And they assumed that the Neanderthals didn't have language. The Neanderthals used different kind of tools. If they used any tools, sort of anatomically modern tools, then they must have stolen them from the anatomically modern human populations, and then eventually were wiped out with good reason by the African humans, the Homo sapiens sapiens. But given the new genetic finds, I think it's much more likely that these were one species with subpopulations. And that subpopulation spread around. And the reason we find much less Neanderthal DNA in our DNA has actually something to do with something different than being wiped out. Those who are not coming from sub-Saharan African origins in today's population have on average, I think, 2.1 or 2.2% admixture of Neanderthal genes. In other words, that much of their genes is coming from the Neanderthal line. But there's a very weird pattern about it, because the Neanderthal genes in these non-sub-Saharan African populations today are only in half of the DNA. So although the rate is very low, and it is around 2, I have a little more than others, than the average, but although the rate is very low, 50% of the DNA has Neanderthal genes in it, but it's evenly distributed. It's not characteristic where it is, which is really weird. And people who work on hybridization in farm animals see exactly the same pattern. And what is happening is that you might have had subpopulations that started to diverge from each other a little bit. And then when they met up and they fell in love and made babies, those babies had a little lower evolutionary success, a little lower fitness, a little fewer kids. And that would explain this weird pattern of the genes. But it will also be a straightforward evidence that it was possible for them to mate with each other. And hence, quite likely, were very, very similar to each other. So these stories about the tools being stolen, and they might not have spoken language and might not have had complex thinking, I think is less likely than the argument that they were really one species. And that is going to then take us to the point of, if this was one species, then that had many, many interbreeding events. Yeah, they had sex. At least 3 in Papua, at least 7 with the Neanderthals. Let's stop sharing and come back here and open up for the chat now. Clint, are you here?
I'm here.
Hey, Clint. Sorry, we didn't get to the war yet.
Hey, how you doing?
Way into. Did you get to listen in?
Yeah, I listened in. I didn't hear much about warfare, but yes.
Yeah. The war is coming a little later. I'm sorry.
War is always coming. Let's not worry about it.
Okay, but do you want to run a little bit of chat about all this stuff I said about tool use?
The tool use thing I've always found to be a bit interesting, not as much in the discussions about the complexity of, how hard is it to make a tool, how nice is it, how sharp is it, but as much as comparing tool use with other technologies, how much time is invested in it. And those logistical questions have always sort of struck me as being a little bit more informative about the lifestyles of our ancestors than just simple concepts like behavioral modernity or symbolic behavior, which I've always found to be a bit of a red herring. So I like that discussion because, in the mid-2000s, everybody was looking for or trying to explain what symbolic behavior was. And if you come at it from a philosophical perspective, almost anything we do ever, any organism can, to some degree engage in symbolic behavior, but it doesn't explain biological differences between species. And that's pretty critical. But I'd like the point you made that some of the activities of Highlanders and Bushmen who are by all means behaviorally modern would not be seen even a few thousand years from now, just because of the materials that they interact with do not persist for the most part, other than stone tools. But beyond that, I don't have a whole lot more to weigh in, because I tend to agree with you on a lot of the points you made.
What do you make of the floresiensis tool package? So the tools that they were using, they, to my untrained eyes, they seem to be the kind of cutting tools that you are making. Less so for tools to make other tools.
That seems about accurate. They look to have like focused on fairly simple cutting tools, and maybe if you were to break it down, maybe more tools for foraging, simple tools regardless. And when you consider the ecosystem and the materials they had at their disposal there, that may give you some of your answers as to why.
Because what I'm trying to figure out is how the tools that, how much we can actually learn from the tools that they were using about the common ancestors tools. So do you think that if you find an assembly of tools for something like the Hobbit, or for Neanderthals, do you, what's your first response, first reaction? Do you think they are going to be parallel, discovered and invented and developed, or do you think that that would tell us about the common ancestor? So let's say that
No, I think you'd get a parallel discovery of tool usage once you get into a species that has the ability to intentionally manipulate the physics of the world around them in that manner, to manufacture novel things. The limits of stone only give you so many options for what you can create with it in those conditions. And so it's going to be, once you have a species that knows how to manipulate the material world to manufacture tools that do other jobs for them, you get second and third order removal from the need. That material is going to be stone or bone or wood. And the stone only offers so many potentials for what you can actually do with it. Physics imposes some basic principles on how conchoidal fracturing works. So once you get into using stone, you are now limited by the physics of silica-rich materials that fracture in cone shapes. So you're going to have a lot of sort of parallel evolutionary trajectories in that regard. So I think you could have discovered it, lost it, discovered it hundreds, thousands of times, even in the same species, to be honest.
So do you think that so if you bring it to the tool set that we are having around us,
Mm-hmm.
so can you make a comparison about the complexity of tool use in these ancestors and today? So I'm talking to you via super complicated technology,
Right.
yeah, obviously, but I know nothing about it. Yeah? I do not need to engage with how a computer works inside. Yeah, what I have is a screen, and you are on my screen. Thank you. And then I have a mug to have some hot water from. Yeah, I mean a container. Yeah, like
Yeah.
so.
Container.
Actual world, it seems complex, but our engagement with it, our individual engagement with it, is not necessarily complicated. So can you compare that to an early human, a Neanderthal? I mean, Denisova is tricky because there's not much.
Well, I would maybe disagree with the idea that it's not a complicated engagement.
How?
You're engaging. I mean, you could view it the way you engage with your computer in the language of computer science as an interface, right? So whatever programming language or Windows or whatever, that's your interface. But every time you adopt or interact with a different technology, you've had to learn that technological interface. Even if you didn't build the computer yourself and get the cobalt from the Congo and fix all the diodes, you know, any of that, you had to learn a novel interface for every single technology you engage with. And if you stop and think, how many technologies do you engage with in a given day or week? Now compare that to, if you'll recall, some of the paleotechnology skills we learned and practiced together. Okay, those are novel technologies, but there's a finite set, a fairly regular set of these technologies you're going to encounter in each ecosystem. Each environment offers, in the words of you know, philosophy or whatever, affordances. But for every single thing you do, where did you get your coffee from?
From the kitchen.
From the what?
The kitchen?
Yeah. What kind of machine did you get it from?
Red.
The red one. Okay. Did you know how to use that machine when you got red machine?
I pushed the button.
I didn't know how to use a damn thing when I got to your house. I was like, what's with this thing?
Yeah.
It's really fancy.
You figured it out, yeah? So.
Well, you know, you showed me. I learned.
Yeah, but look at this.
The language.
This has a single button on it.
Yeah.
It can recognize
That
my fingerprint, but it has only one button.
But that button opens up like 20 other, 1,000 different affordances and options. Think of all the cognitive processes, all the decisions you have to make. How many applications do you have on your phone? Every one of those has a new interface you have to learn. Now, maybe some of those are more intuitive because they're Android-based or iPhone-based, but every one of those is a technologically complex set of processes. Just the same way you learning how to use cattail for more than just making reed mats or grinding it into flour.
Can I just say that I'm on Tamash's side? There is a difference in degree, maybe a little bit, but I think there's still a huge leap. I think that the kind of things that we learn to deal with in our lives, in every generation, have, from the individual's perspective, similar complexities in the sense of what you need to learn and what you need to understand. And what changes is the technological environment. And I mean, this can't be entirely true in the extreme way. Yeah, so I agree with you. I mean, we have these extremely rich environments now to interact with, which also means that our repertoire is maybe somewhat bigger than it used to be many generations back. But at the same time, I think I'm on your side, Tamas, that my individual part of interacting with these things is nothing compared to the giant leap. If you see what sort of the change in that environment is that what you're defending, Tamas?
Yeah, I mean that's my question, Clint. What do you
Frame the question again, please?
So what I'd like to know, if we can. So the ultimate question is why we haven't screwed up the planet for such a long time. Yeah, and then we will tell some stories around agriculture or whatever. But before that, we had this really long period, maybe 300,000 years. I argue maybe 800,000 years, in which we were foragers, and we were foragers very, very similar to who we are today. With this, the capacity of spoken language, complex communication, complex tools, so teaching each other, learning. And so when we find something today, like an assembly of tools in the Neanderthal site, or an assembly of tools on Flores, on the Hobbit site, and we try to, from that, backward extrapolate the complexity of their thinking, will that inform us to where this point of complex thinking, the being that was already like us, happened? Yeah. So the reason I ask, yeah.
I guess my answer would be, I don't think we will get it from the tools alone. because some of the tools are just tools and can be made by species that do not require quite the cognitive complexity that we do. I think you can only really get that by understanding that nexus of their behavior, their ecosystem. What were they doing? How were they thinking? That I don't think you're just going to get from the tools.
And hence, we need to really understand more about the genes, because we will not have other information.
I can
Cool.
hear you, Beth.
I said, and then we need to understand more about the genes, the shared genes that we have, because.
Sure.
All right.
The genes help.
Well, might help. We'll see. All right. Let's move on to the Neanderthals. I mean, Neanderthal story, I think in many ways, I started with the Denisovans because they were more important for me because of my New Guinea work. But the Neanderthals were in many ways similar to the Denisovan story, but just earlier. But it was really interesting to see how people didn't like the idea that Neanderthals were similar to us. I'm not quite sure why, but the more you would find, the more you would realize that the Neanderthals were similar to us. Here's a bit of discussion of who's how far from who, and it is very clear that there was a really complex pattern of interbreeding among Neanderthals and Denisovans and African humans and then later Asian humans. And all of that, I think, argues for, let me jump over all of this, which shows that a lot of interbreeding, and all of that suggests that we might have been around for much longer than what we thought we were around for. There is a particular point about 800,000 years when there seems to have been a shift from bodily adaptation that Homo erectus characterized Homo erectus to mostly cultural adaptation. So Homo erectus clearly had adaptation in the tools as well, but a lot of adaptation in the body. And Homo heidelbergensis, from about 800,000 years ago, started to, it seems, much less in the body and much more in the tools. And then that's the point where there was a split from the African Homo sapiens and the Asian Denisovan Homo sapiens. And a little later was the split from the African Homo sapiens and the European Neanderthal Homo sapiens, but with clearly interbreeding in many ways. So let me just. So we end up with this in this world. I find this a very useful map for this. In this world where you have somehow, I mean, this particular one puts it at 650,000 years, where you have a split among the African, Asian, and European populations. Let's call one of them the African anatomically modern human is the standard term, the European and Neanderthal, and the Denisovan is the Asian one. But it's very clear that the situation is much more complex. So there were clearly interbreeding episodes a lot of times among them, between the African anatomically modern human and the European Neanderthal. At least 7 times can be proven from the DNA pool that we see today. And there was at least one other unknown hominin for which there are no bones yet, but you can see the signature of it in our genes. So the whole thing is a mess out there. And clearly at the same time, the climate was changing. So all of this was happening when very cold periods were in between were peppered with hot periods. Yeah. So if you look at the pattern, I will show you a little bit later, a pattern of this 800,000 years, the pattern of temperature, much of it is much, much colder than it is now. So the ice cap was moving up and down all the time, creating pressures all the time. So for instance, in the past 800,000 years, the British Isles were occupied and then lost and occupied and lost at least 8 times. So there were a lot of pressure towards migration. We don't think about this, yeah? So I'm dwelling on this for such a long time because it bothers me a little bit that all our current thinking about species is since agriculture appeared, and we do not actually think about what happened in that 800,000 years, or if you like, that the species evolved later, 350,000 years. What happened in all that time? Partially we don't know, partially because we don't have any kind of, we don't have our focus on it. And then, and then we get to the point where the latest outing from Africa comes out. But even if I show you this 2017 graph to an anthropology 2020, archaeology 2020 working on this, will point out that the days are off, the years are off, the dates are off. So it's a mess. And if you look at the actual graph of the DNA, it's a giant mess. So we really facing a much more complex story for our species that's simplistic split from anatomically modern humans, from Neanderthals and the later Denisovans. And sort of it takes me to this question of why have we not messed up the planet? Why is it that this super smart species that is so good at manipulating the environment, that spread around the world in many, many ways, did not mess up the planet? And then one obvious answer is that we were foragers. So in all this period, we had a forager's engagement with the environment. And the forager's engagement is a short-term one. So although we had by this time the capacity for technological investment to wait and build complicated technologies, when the environment is unpredictable, when there's a lot of movement in the climate, we can't really predict ahead. So that unpredictability of the environment shortens our time horizon. So we might be able to cook, we might be able to build complex technologies that requires the ability to wait and patience. But we are still not having the ability to look ahead and plan ahead. So we become foraging apes, efficiently foraging apes. Like all the others, we just had tools and we just had weapons. So we were better at it. And that, of course, had a consequence that because we were good at it, we had some effect on the environment. So we know that if there were species around that were easy to hunt, high value, and few in number, and slowly reproducing, they were often wiped out by the arrival of these super smart humans. So easy to access, easy to hunt, so you can find them, they're high value, so you're going to pursue them, and few in number, so you kill enough of them, you hit a threshold, and they will die out. But that's it seems. There was no mass effect that is happening today. So that would suggest that our species is not inherently bad. Sort of maybe an obvious point, but we are not inherent, it's not necessary that we are screwing up the planet. We are just an opportunistic ape, super smart ape, and responding to the conditions. So when the conditions were that we are foragers and we limit the extent we have an impact on the environment, that's what we did. And then when the conditions changed, to which I'll come back with when we discuss the rise of agriculture within the metrocracy part, I will show you how conditions change and the agriculture rises. Then we start having this giant impact that resulted in the situation where we are now. Right. So, and with that, we finished the second segment. The Human Bee series is about understanding who we are as a species so that we can equip ourselves to take responsibility for the planet. Because if we humans are not going to do that, there's nobody else who's going to save the biosphere. If you'd like to be part of this conversation, please subscribe here now.